identify the x-intercepts, y-intercept smallest possible degree and write a possible equation for the polynomial graph below. So the x-intercepts are where the graph is hitting this horizontal x-axis. They're happening here, here, and here. The x-intercepts are at -1, zero, and +1. The y-intercept is where this graph hits this vertical axis right there. So it's right here. Well, that is y-intercept is at 0. Okay, what's the smallest possible degree that this polynomial is? Well, there's actually two different theorems. The easiest for me to remember is you just count the intercepts. Because each intercept, as we saw from the previous problem here, that there was 3 different factors. Well, when we have 3 different intercepts, all of those intercepts can be written back as factors of the original function. So I know every x-intercept I have is one of the factors of the original equation. And it's gonna contribute, every intercept contributes at least 1 to the degree of the polynomial. So there are 3 x-intercepts. So based on that, I can say there's at least 3. This is at least, maybe more, it's at least a degree 3 polynomial. Degree 3 polynomial means that the highest degree on the polynomial, or highest exponent on the x, is 3. Then there's another theorem that says, hey, if we have, for every term we have, if we think about like the x squared, we know this is what x squared looks like. It's a bowl. So so notice how we're going up, we're going up, we're going up, and then we turn around and keep coming down. That's a turn. So actually, I know that this function, it is actually x squared. And the exponent on the highest exponent was x squared. And we saw just 1 turn. So actually, for every turn that a function has, it adds 1 to the degree of the polynomial. Well, actually, you just count the number of turns and then you add 1, and you know that that's the smallest possible degree of the polynomial. So like I see in this picture, there is 1 turn. So if I add 1 to that, then that will be the least degree polynomial that that picture could possibly be. So I'm going to count my number of turns in this picture. So I'm going up, going up, going up, turn, going down, turn, going down, turn. So there was 1, 2, 3 turns. So there's 3 turns. And they say that the least this could be is 3 plus 1. So this is a degree 4 or higher polynomial, which is actually bigger than 3. So from the first theorem, just looking at the x-intercepts, so we could determine that it was at least a degree 3, but actually looking at the terms, we know it's a degree 4 or higher. Also, I can look at the long run behavior. I've noticed if I keep going, I mean, I'm assuming if we keep going, from what I can tell about from this picture, my best educated guess is, from what I can see, is that it's going down and it's going down. So the general picture kind of looks like a big bowl, sort of, going down. So it's telling me that this is probably a degree 4, and it's a negative degree 4 because it's flipped. Because it's a bowl shaped in general, and I know it's an even degree polynomial. And I say bowl shaped, I'm just looking at the tails, not at this curvy, right? I'm just looking at the end tails. So the end tails kind of make it look like a bowl. So it's bowl shaped, so it's an even degree. And it actually looks like an upside down bowl. So it's a negative even degree. Okay, now let's talk about the multiplicity of each point. Let's talk about the multiplicity. So based on the x-intercepts, the fact that we have an x-intercept negative 1, I'm thinking that there's at least one factor that's x plus 1. That's the only way I could get an x-intercept of negative 1. If I have a factor in this function. Then I have a factor of 0. So that's just coming from x. Then I have a factor of positive 1, which would come from a factor of x minus 1. So those are my 3 factors I have for sure because of the intercepts. Because this would lead to x equals 1. That's why we have an x-intercept of 1. This would lead to x equals negative 1. And this would lead to x equals 0. And that's why we'd have the intercepts that we would have. Now let's talk about the behavior of the graph right around those intercepts. So if I really scroll in, and I'm just focused around this point negative 1, notice it looks like a straight line. I'm just focused around a direct area around negative 1. Because of the straight line, to me, that tells me that this factor has an exponent of 1. And when I scroll in around the the x, the positive one, it kind of looks like, sort of to me, like it kind of comes down and then it kind of comes back up. So it's bouncing. It kind of comes, it hits there and it bounces back up. So because of that, I'm thinking that it's maybe possibly a square because it kind of looks parabolish around that x equals 1 intercept. So I would call that it probably has a square on that factor. And when I look at the picture right around 0, it kind of just comes down and then comes through and then just goes straight down. So it resembles just a straight line around 0. So I'm thinking the exponent on that is also just 1. So these numbers on the top, I'm not sure if I introduced this to you, this is called the multiplicity of each factor. So this is probably my best guess for that equation. Ooh, except for it's negative. I didn't write a negative sign. So it's probably a negative all of this. So it's probably f of x equals negative x, x plus 1, x minus 1 squared. And just so I know, if I focus on the largest term in all of these factors, that would end up being my largest leading coefficient. So I would do x times x times x. This would be x squared after we get done multiplying that out. This would be x squared. So it'd be x times x times x squared, which would be x to the fourth. This, when I multiply this out, it would be a degree 4 polynomial, just like we kind of thought it might be, the even degree, just like we thought it would be. So I think that this is a good guess. I might be wrong. I mean, this could be a degree of 4. And these might, so this is just an estimate, but this is a pretty good guess of what this equation probably is. All right, thanks for watching.